Good morning, everyone. My name is Julio, and my partner is Valencia Angelica. Today, we'll present our research paper. For our paper, the title is Predicting Customer and Sentiment in E-commerce, leveraging naive Bayes and superfactor machine models using the Twitter API. For the introduction, there's several points. Sentiment analysis, also known as opinion mining, involves identifying, extracting, and evaluating subjective data in text using natural language processing techniques. In the current digital era, where the internet permeates every facet of daily life, sentiment analysis has become crucial. As consumers increasingly express their opinion online, understanding these sentiments can provide valuable insights into public opinion, aiding businesses. The commercial value. Online reviews have significant commercial value as they provide extensive and genuine insights into customer experience with products and services. With the rapid growth of e-commerce, the subjective opinions expressed by consumers online have become increasingly important. And then the benefits of online reviews, there are three types. First one is consumer insights. Online reviews reveal what people believe, how they think, and their emotional response, helping other consumers make informed decisions. Business feedback. Reviews help businesses understand customer satisfaction, preferences, and expectation. For the dual purpose, reviews serve both as product evaluation and as mean to gain deeper insights into consumer perceptions and interactions. The objective of the research is to analyze sentiments held in TikTok, Shopee, and Zalora reviews and comments using naive Bayes and superfactor machine sentiment analysis algorithms. The study focuses on posts from the Twitter platform, aiming to categorize reviews and comments into positive, negative, or neutral sentiments. The next one is limitation of study. Despite the efficiency of naive Bayes and superfactor machine algorithms in learning and predicting sentiment from social media comments, this method have limitation. Specifically, they struggle to accurately understand and analyze tweets due to the nature of informal language use of sarcasm and local specific sentiments. And then for the literature review, there are two most important things that we have here. The first one is effectiveness of sentiment analysis. In a 2020 study, a method using Latent direct location achieved high scores in precision, recall, and F1 score. In 2021, three classifiers as Gaussian naive Bayes, superfactor machine, and random forest were evaluated and then achieved the highest accuracy with ISRI, Stemmer, and ARL, Stemmer. The second one, text classification in different languages. For English text classification, combining the Lancaster and Porter stemming algorithms, the SVM model achieved the highest accuracy while the KNN model had the lowest. For Bangla text, the SVM model also performed best with an accuracy, while the KNN model had the poorest performance. And then we go to the workflow. This is our workflow where it has to connect it to the methodology. There are two methods. One is qualitative and the second one is quantitative. For the qualitative is such as data collecting, where it employed the Twitter API to collect tweets and public posts mentioning Zalora, Shopee, and TikTok, web crawling process using Python to download the data. For a quantitative method, the first one is text pre-processing, where we have to remove unwanted characters, symbol, HTML text, and punctuation, converting text to lowercase and transforming informal words to their proper word forms. And then we have to remove common words to reduce noise, and then tokenization and converting words to their base forms, and then translating text from Bahasa to English. The second one is data labeling, annotating the data with labels for positive, neutral, and negative sentiments using the text block library based on polarity. And then training and testing. We have to splitting the data set into training and testing using the holdout method. And then we have to transforming the data set into numerical factors using the TF-IDF technique. And then we have to training the naive Bayes and superfactor machine models on the training data. The last one, we have to testing the models on the testing data to check their efficiency. And then the last one is we have model evaluation, where we have to determine the efficiency of models and the accuracy of the models or algorithms. And then we use the confusion matrix along with precision, recall F1 score, and accuracy matrix to present evaluation measures. And then we have the results right here.
We will go with the results and discussions. The table 1 shows us the distributed percentage from the platform TikTok Shop, Zalora, and Shopee platform. And this table shows us distributed percentage for the cost positive, neutral, and negative. And we use the private crawling method to collect the dataset from of the TikTok Shop, Shopee, and Zalora using the Twitter API. And as you can see here, from those three platforms, those all achieves the highest tweets in positive causes, followed by the neutral and the negative tweets. For the positive causes that we got, for example, the word baik, bagus, and berkualitas. For the negative tweets that we got from the crawling method, for instance, buruk, jelek, and tidak bagus. And for the neutral tweets commonly said about the adequate or of the quality and the services on those platforms. Next. And here is the table of the performance evaluation for those two models. For the table 2, the naive bias performance metrics, and we use the precision, recall, and F1 score to evaluate the model. For the table 2, we use the TikTok Shop platform as it achieves the highest among the two platforms on the naive bias model. And I'm gonna explain about the negative cause. The precision achieves 100%, means that all tweets that are predicted as negative are truly negative. Only 33% of the actual negative were correctly identified. And meanwhile, the F1 score only gets 50%, means the balance of the negative cause in the naive bias method is not really good in this Shopee dataset. And and the table 3 shows the support vector support vector machine model using the Shopee platform. And the precision of the negative class is also 100%. That means that all tweets that are predicted as negative are truly negative, and 67, 67% of the actual negative instance were correctly identified. And this table 4 shows us the overall accuracy that achieved from the naive bias and the SVM model using the Shopee dataset. And this table shows us that the accuracy using the Shopee platform dataset got the highest overall accuracy by the support vector machine model. And from all classes, SVM leads the number of accuracy compared to the naive bias model. And in this study, the dataset is expected to be more diverse and more variant to improve the accuracy number. Because from the previous table that shows the performance metrics, we can see that the number of the precision, recall, and F1 score from the two models is not quite good, and we can say that it can be improved if we have more time to crawl more dataset and make the datasets more diverse and more variant. And next. And for the conclusion, we can conclude that this study has proved that both of support vector machine and naive bias can be used to analyze the public sentiment, and this can be helped to determine and analyze the market trend using machine learning for those platforms, especially the e-commerce platform. And for this, in this study, from the result that I have explained before, this study achieves the highest number of accuracy on the support vector machine model compared to the naive bias model, with the accuracy number of
90%.
in the neutral class on the Shopee platform. And however, we recommend to the next and to the future study to make an improvement, especially with the dataset, and it can be used a more diverse and variant of dataset to get a better performance on those models. And here are some list of recommendations that we can give to the next or to the future study. For the first one is to apply a transformation-based model such as BERT to enhance sentiment analysis. And the second one is to try integrating other machine learning techniques such as random forest or neural network to further improve the analysis sentiment.